Welcome to the second video of Module 4 on solving for the unknown in a logarithmic expression. In this example, we're going to be solving for the unknown on the left-hand side. Given question A, y is equal to log of base 10 of 100. We are looking to solve for the value of y. Step 1 of this solution is to determine what we are asked to find. So are we looking for the exponent, the base, or the number in our logarithmic expression? Here we are looking for the exponent. We're looking for y. In step 2, we want to rewrite our expression in exponential form. Rewritten in exponential form, we get 10 to the power of y is equal to 100. In step 3, we want to determine the exponent. What you need to ask yourself is what exponent must we raise base 10 to in order to obtain 100? So recall that 100 is equal to 10 to the power of 2. Therefore, our exponent, or the missing value, is y is equal to 2. We can verify this using our calculator by evaluating log of 100. Remember, when we have a base 10, it's a common logarithm and you just use the log button. So log of 100 is equal to, and you should get 2. In part B, we have h plus is equal to log of base 3 of 9. In the solution for step 1, we consider what we are asked to find. We're given an expression in logarithmic form, and we have the unknown as part of the exponent, so we're looking for the value of the exponent. Step 2 says to rewrite the expression in exponential form. So although our variable, our missing value, looks like a combination of symbols, it just represents a single variable, similar to having a variable of x. So in exponential form, we get that our base of 3 to the exponent of h plus is equal to 9. We want to determine the value of the exponent. So ask yourself, what exponent must we raise a base 3 to in order to obtain a value of 9? We know that 3 to the power of 2 is equal to 9. Therefore, h plus is equal to 2. And H plus is the hydrogen ion concentration, which will appear later on in our calculation for pH. We're going to look at how to evaluate log of base 3 of 9 using your calculator. Remember, the log function on your calculator, so your log button, assumes that we are working with a base 10 log. And our expression is not in base 10. Therefore, we need to use different methodology. Anytime we want to evaluate a log of a base other than 10 on our calculator, so we have log of base b of x, we can evaluate it using our log of base 10 button. So it's equal to log of base 10 of x divided by log of base 10 of our base b. So that's log of x divided by log of b. In this particular example, because we have the log of base 3 of 9, we can evaluate it using log of 9 divided by log of our base, which is 3, and that is equal to 2. So on your calculator, we need to use the log button twice. You're going to use log of 9 divided by log of 3 is equal to, and you'll find that the value is equal to 2. Pause your video and attempt the 2 practice problems, then watch the solutions. In part A, we have evaluate y is equal to log of base 10 of 0.0001. Considering this in exponential form, we have 10 to the power of y is equal to 0.0001. We know that 10 to the minus 4 is equal to 0.0001. Therefore, y is equal to negative 4. Also, evaluating this on our calculator using your log button, log of 0.0001 is equal to negative 4. In part B, we have y is equal to log of base 2 of 0.125. And when we evaluate this in our calculator, we get log of the number. And since our base is other than 10, we need to divide by log of our base of 2. And we find that y is equal to -3. Of course, this is because 2 to the power of -3 is equal to 0.125. In the next example, we're going to look at solving for the unknown when the unknown is inside our logarithm. So we have 3 is equal to log of base 10 of x. And in the previous examples, all of our unknowns were on the left-hand side, but now our unknown of x is inside our logarithm. Step 1 of our solution is to determine if we are being asked to find the exponent, the base, or the number. And what we're looking for in this case is the number. So we rewrite the expression in exponential form. So we have a base of 10, an exponent of 3, and it is equal to our number x. So we want to determine the number. You ask yourself, what is the value of 10 raised to the exponent of 3? And we know that 10 to the power of 3 is 1,000, therefore x is equal to 1,000. Okay, to evaluate this on your calculator, we first put our expression into exponential form. We know that x is equal to 10 to the power of 3. We evaluate that on our calculator, and we find that the answer is, in fact, 1,000. Now pause the video and practice, then compare your solutions to what is posted here. Log of p of base 5 is equal to 6. We get p is equal to 5 to the power of 6. Evaluating this on your calculator, you find that the final answer is 15,625. So we have log of base 10 of 100,000 is equal to a. So a, we can rewrite 100,000 as 10 to the power of 5, and we have log of base 10 of 10 to the power of 5, which is equal to 5. In part C, we have that log of base 10 of p is equal to 1.54785. So we find p by taking our implied base of 10 and raising it to the exponent of 1.54785. Now evaluate this on your calculator and you will find that the final answer is 35.31 when rounded to 2 decimal places. Part D, we have log of base 10 of k is equal to 0.3263. We can express our number k as being equal to 10 to the power of 0.3263. Evaluate this on your calculator and you will find that the final answer is 2.12 when rounded to 2 decimal places. Part E, we have log of base 2 of 32 is equal to a. A is equal to log of 32 divided by log 2, which is equal to 5. In part F, we have log of base 2 of 1/4 is equal to a. So we get a is equal to log of 1/4 divided by log of base 2, our base, which is equal to -2. One thing to note here is that when you're writing log of 1/4 in your calculator, make sure that the 1/4 is in the brackets, because log of 1/4 does not equal log of 1 divided by 4, which if the full 1/4 is not in the brackets, that's how your calculator will see it, that you are dividing log of 1 by 4. In part G, we have log of base 8 of 512 is equal to a. So we have a is equal to the log of 512 divided by log of 8, which is equal to 3. So we know that 8 to the power of 3 is equal to 512. Now that we know how to work between an exponential and a logarithmic equation, as well as solve for unknowns in exponential and logarithmic equations, we're going to move on to some application problems. So well done. We've gotten through the necessary information to get to the exciting application problems.